right, exercise 5E or 6E if you're on the extension textbook. Like to start off by reminding you about what we did yesterday. So yesterday, if we had just like a generic angle, I'm going to call it theta because it's a generic angle, then that angle is the opposite of it going up. I'm going to call it y because it's going up, y units because it's going up, it's in the y direction. I'm going to call the adjacent x because it's going along x in the x direction, and the radius is r. So then sine of that angle theta is opposite over hypotenuse, so y over r, then cos is x over r, tan is y over x, opposite over adjacent. We know this, we've done this. And literally, I'm going to repeat myself again, it's just so this is more visually appealing. So this point, the x-coordinate is x, the y-coordinate is y, and the radius is r, yeah? So for this one, and this angle is theta. So sine theta equals y over r, cos theta equals x over r, and tan theta equals y over x. Now, if I'm now not looking at that angle, I'm looking at this angle instead, and this angle just so happens to be theta up from here. So it's actually 180 minus theta. So if theta was 30, then this angle is actually 150. So I'm looking at the angle 150, not the angle 30, but I'm going to discover some shortcuts. Then sine of the angle that we're looking at, this P, this point, is now minus x, comma, it's still positive y because now we're in the negative x, but we're still positive y, and the radius is still r. So now, now it's 180, take, it just so happens to be the same as 180 minus the angle that we looked at in the first case is minus y on r. So, it's still positive y on r because we're in the positive x direction, which is just sine what we had in the first quadrant. So if we're looking at sine 150, it's the same as sine 30. So, but if I'm looking at cos, for example, 150, then this would be minus x on r, which would be minus cos theta. And if I'm looking at tan, it's y on minus x, which gives me negative tan theta. So, for example, sine 150 equals just the same as sine 30, but cos 150 equals negative cos 30, and tan 150 equals negative tan 30. So you may know tan cos sine 30 already, but we don't know sine cos tan 150, but we kind of do because we can just chuck negatives in front of it. Third quadrant. So this time I'm looking down here. Now we're coincidentally, our angle is coincidentally theta down from 180. So this whole angle from 0 is 180 plus theta. And our point is negative x, negative y, because we're x across. We're negative x across, and we're negative y down. So this time, sine of 180 plus theta. So for example, this time it might be 210 degrees, which is, 30 more than 180, equals minus y over r, which is minus sine theta. So for example, if I wanted sine 210, I'd do minus sine theta. Cos 180 plus theta equals minus x over r, which gives me minus cos theta. And tan 180 plus theta equals minus y over minus x. The minuses cancel out, so that's y on x, so that's positive tan theta. So for example, sine 210 equals negative sine 30. Cos 210 equals negative cos 30. But tan 210 just equals positive tan 30. I'm going to pull that one over to the left. Okay. Just trying to fit it all in, hey? Okay, and you can probably guess what's going to happen with the fourth quadrant. So now I'm here. My angle just so happens to be theta down from 360, which means my angle is actually 360 minus theta, which means my x is now positive x, my y is negative y, and the point that I'm ending up at is p positive x negative y. So let's have a look at what we get with sine, cos and tan. And why is this arrow just in a random spot? Okay. Sine 360 take theta is the same as, is now negative y over r, so it's negative sine of just theta. So for example, if I was looking at the angle 330 degrees, then sine 330 is negative sine 30. Cos 360 take theta equals x over r, which is positive cos theta. And tan 360 take theta equals negative y over positive x, which is negative tan theta. So, for example, sine 330, well, that's going to be negative sine 30. Tan 3, but cos 330 equals positive cos 30, while tan 330 is negative again. Before we get on to two special triangles and putting it all together, a way to remember which one's positive. Remembering which is positive. Because all the time, you're going to kind of drag it back to, if you're ever given an angle that's more than just 90, you're going to drag it back to like its acute angle under it, so the angle between it and the horizontal line, and then decide whether you're going to chuck a minus or a plus in front of it. So to remember which is positive, the acronym they like to use, ASTC, all stations to central. So all positive. Sine positive. Tan positive. Cos positive. Or I like to use sex and the city, probably because when I learnt about this, I was a very impressionable 16-year-old and enjoyed watching that show, which is, when you look back at it, it's not a great show. Okay, 2 special triangles to keep in mind while you're doing these types of problems. Same 2 special triangles that we've been learning about all the time. So, sometime soon you should be able to do these off the top of your head. So if this is 30, this is 1 and this is 2. If that's 1 and 2, this is root 3. If that's 30, this is right angle, this is 60. The next one is our 45-degree triangle. So if that's 45 and this is 1, if it's 45, they must be the same. So this is also 1. If that's 1 and 1, this must be root 2. Putting it all together. So for example, find sine, I'm going to ask you to find sine 45 cos 120 and tan 225, and then I'm going to ask you to find sine 330. Now, sine 45 is really easy. We're just looking at our 45-degree triangle. So it's opposite over adjacent, so it's 1 on root 2. Cos 120. Now, this is the second quadrant. So cos 120 equals minus cos 180 minus 120. So it's minus cos 60. Cos 60, if we have a look at our triangle, it's 1 on 2, adjacent over hypotenuse. So it's minus 1 on 2. Tan 225, we're now in the third quadrant. Tan is positive in this quadrant, so tan 225 equals positive tan 225 plus theta. Like, what is this theta? 180 plus theta. So this theta is 180 plus theta. So to figure out this theta, you do 225 minus 180. So really, I should have written theta take 180. My apologies if you were writing this as we go. So this would be 225 take 180. So it's positive tan 45. And tan 45, 1 on 1. So it's positive 1. Finally, sine 30, this is the fourth quadrant. So sine 330 equals, sine's negative in this one, so negative sine 360 minus 330. So that's negative sine 30. So it's negative. Now if we look at our triangle, sine 30 opposite over hypotenuse, 1 on 2. So it's negative a half. And that's kind of how you do it.